welcome to my Graphene TED Talk, and today I'll be going over the material graphene with you. So, first of all, the major thing, what is graphene? Graphene is a single layer of carbon atoms tightly bound in a hexagonal honeycomb lattice. It is an allotrope of carbon, meaning that it has the property to exist in two or more different forms while maintaining the same physical state. Graphite is a material that many might have heard of before. This is just the name for multiple layers of graphene fixed on top of each other. The individual layers of graphene and graphite are held together by something called van der Waals forces, a type of attraction that neither falls into the covalent or ionic bonds description. The van der Waals force can be overcome during the exfoliation, which means the shedding of dead skin. In this case, it's the flakes of graphene turning into graphite. Now, we're going on to the properties of graphene. So, the cool thing about graphene is that not only is it the thinnest compound known to man, at only 1 atom thick, it is also the lightest material known, with 1 whole square meter weighing less than a single milligram. Graphene has been measured to be the most robust material discovered yet as well, being almost 200 times stronger than steel by weight. Furthermore, graphene is also the best conductor of both heat and electricity at room temperature. With all this in mind, graphene might be considered a costly material to produce since the molecular structure is densely packed. Graphene being hard to acquire might have been true a decade or two ago. However, in the present, this is quite far from the truth. Graphite's main ingredient is carbon, and carbon is the 4th most abundant substance in the universe, following hydrogen, helium, and oxygen. This essentially means that graphene would turn into an eco-friendly, cheap, and reliable material with little research and experiments needed. As of today, the cheapest, most reliable, and most straightforward way to make graphene is surprisingly uncomplicated. Everything required will only contain some water, a blender, some graphite powder, and some dishwashing liquid. Insert all the items into a blender in any order, blend it, and it will have created one of the world's most magnificent substances. Now we're going on to the history of graphene. Graphene has been studied hypothetically for numerous years. However, only recently, in 2004, has it been isolated into real life by physicists, students Andrei Geim, Konstantin Novoselov, and other collaborators at the University of Manchester in the UK. Their initial question was, can we make a transistor out of graphite? During their research, Geim and Novoselov extracted thin layers of graphite from a graphite crystal using Scotch tape. They then transferred these layers to a silicone substrate and then attached electrodes and created a transistor. Those researchers won the Nobel Prize for Physics in 2010. Research into the area of graphene has progressed phenomenally because of their studies. Many companies have started developing commercial products using this fascinating material. As far as research has shown, the first ever product that has included graphene is the Siren Technology Security Smart Packaging, which uses Vorbeck materials, graphene-based ink. Some companies have announced some graphene-based products, however, sources do not seem as credible as would be preferred, and there has yet to be enough information proving it. Shanghai's Power Booster Technology has declared claims on producing millions of these panels each month, and proclaimed that all these panels are already being shipped to smartphone makers in China. However, none of this has been confirmed yet either. So, we are now moving on to graphene in real life. Graphene can be applied to daily life very quickly and efficiently as well. Scientists in Australia have found a way to make graphene cheap and easy to produce. The pricing of producing a single gram of graphene is $100 currently. After the scientists there figure out the eco-friendly way of creating it, they claim they will drop the price down all the way to 50 cents for 1 gram of graphene. 1 gram might not seem like much, however, it should be noted that 1 square meter, as mentioned above, weighs less than 0.77 milligrams. If graphene were to be introduced into the textile industry, clothing producers could significantly decrease the prices of products created and increase the lifespan of them, since graphene is strong, flexible, and light. A downside to this idea may be that graphene is too thin. It is practically see-through. If someone were to make clothes with it, they will still need to include a non-see-through material layer. However, we cannot tell how society will advance at that time. Maybe our ideals on the human body and censorship would have changed already. Graphene might also be able to migrate into the electronic market. As mentioned above, many companies are starting to take advantage of this material, creating screens for mobile phones, batteries for electronic devices, and even cables wiring. So, now we're going on to the major factors regarding graphene. First are the moral and ethical factors. Before heading too deep into these two subjects, both words' definitions should be clarified. Morals refers to a person's standards of behavior or beliefs concerning what is and is not acceptable for them to do. With ethics, it is practically the same definition, however only in this case it is applied to the entire society, and also in a much more complicated system. Generally, the subject would most likely be on an idea or concept when referring to morals and ethics. However, in this case, it is a piece of technology that has no way of delivering a thought on its own. One way the development and expansion of graphene are affected by these two factors is if a company manages to create a monopoly on creating or marketing the material itself, since only then will it include balancing of interests, one of the 7 principles of ethics. Another example of morals and ethics being connected with graphene is creating weapons. Would using a graphene-based product as a weapon be an ethical thing to do? Perhaps only time will tell. Graphene is not in a state where we can judge factors like this with little knowledge of how it will turn out in the future. Similar to the usage of any other mass-produced material, like plastic or steel, criticizing the potential products that it can produce should be considered silly by many. When the scientists had invented steel, an alloy of the iron that includes small amounts of carbon and chromium inside, they had never thought these materials would be used to create man-killing machines. Blaming them or the material itself for such actions is trivial and senseless. Now we go on to the political and social factors. Creating weapons using graphene might be connected to politics more so than ethics, since the government might want to control the number of products created by this material. Graphene is a non-metal, but is usually known as a quasi-metal because its properties are similar to semiconducting metals. Because of graphene's inability to be detected by metal detectors, it might be put under the same attention as the currently happening 3D printed plastic guns. People would potentially create powerful and unstable possessions right in their homes and cause much distress to the society. Now, onto environmental factors. Graphene's properties all point towards it being a fantastic material, which is not wrong. However, this idea would only make sense if graphene's production is entirely perfect. As it is widely known, graphene is the Earth's most robust and smallest material. This means that if a small piece of it breaks off the main chunk, it can potentially cause much harm. Picture this, a small graphene plane only at 1 atom thick, floating around the air breathed by us. If someone were unfortunate enough to inhale it, the graphene plane could enter the lungs. Imagine the impact it would have if 1 atom were to enter a cell. It could disrupt the cell's normal DNA. If said cell would then multiply, it could cause hazardous cancer to be dealt with by doctors. All this damage would only be caused by 1 single atom of graphene. Imagine if a large-sized production company were to have a breakout. Billions upon billions of graphene atoms would be released into the air. What would the outcome be then? It will not only affect human lives, animals and plants will also suffer because of inadequate protection and security measures from companies constructing this material. A resolution to this would be to limit only the good and suitable companies with enough security measures embedded within the cycle of graphene production to sell and market this material. And finally, to the conclusion, overall, it is undeniable that graphene is a wonderless material that would solve many issues that are in our lives today. However, caution is still required and indispensable. If scientists can effectively, reliably, and safely create this product soon, we will see massive improvements worldwide. I hope you enjoyed this! Thank you, everybody! Bye-bye.